for today's discussion is the third most prominent type of prompt engineering in generative AI, that is chain of thought prompting. In this video, I'll be introducing what exactly is meant by chain of thought prompting. Post that, we'll be delving into the two major types of chain of thought prompting. And thirdly, we'll learn to implement the chain of thought prompting in a Python notebook, practically, wherein we'll learn the difference between chain of thought prompting and the two prompt engineering types that we have learned already, that is zero shot prompting and few shot prompting. And we'll also learn how chain of thought prompting is more efficient as compared to those two types if we have a very complex problem to solve. Now, coming to the introduction to what exactly is meant by chain of thought prompting. In the last two videos where we discussed regarding zero shot prompt engineering and multi-shot prompt engineering, in zero shot prompting, we use the base knowledge of the large language model or the pre-trained knowledge of the large language model to solve the business problem at hand. We do not fine tune the model or train the model, or we do not expose the model to any examples for it to reference from. If the problem is very complex to solve and we do not get the right response using zero shot prompting, we use multi shot prompting, wherein we expose the model to one or few examples for it to reference from and give us the expected output. Let's take a scenario wherein the problem is so complex that it is not being able to solve using few shot prompting as well. We resort to chain of thought prompting, where we improve the performance of the large language model on these type of complex tasks, the tasks which are not being able to solve using few shot prompting as well, these type of complex tasks, by encouraging them to generate intermediate reasoning steps for these complex problems. That is, this method helps the model to break down a complex problem or a complex reasoning problem into smaller, more manageable parts, and we explicitly articulate these steps for the model to reach a expected output or the right output. Let's try to understand this using this example on the right hand side, where we have a task to solve this particular mathematics problem, right? The problem is, I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 to the repairman. I then went and bought 5 more apples and ate one. How many apples did I remain with? If I were to solve this problem using chain of thought prompting, what I would do is I'll break down this problem into more manageable parts and ask the model to solve any further problem of this particular type in this particular fashion by breaking the problem into such manageable parts and doing it step by step. For instance, I'll ask the model to, let's break down the problem step by step. Start with 10 apples, then give 2 apples to the neighbor so that I have 10 minus 2, that is 8 apples. Give 2 apples to the repairman so that of the 8 apples I am left with 6 apples. Then I bought 5 more apples so that I have a total of 11 apples now. I eat one of those, I am remaining with 10 apples, and hence I get 10 apples as the desired output at the end. So we are breaking each and every step and explicitly articulating that to the large language model and asking it to follow these steps one by one if the large language model encounters a problem of such type. Instead of directly giving an output of 10 apples over here, I am breaking it down, breaking this complex problem into subparts or manageable parts for the model to give us the desired output, right output at the end. Now let's try to comprehend the types of chain of thought prompting. The first prominent type of chain of thought prompting is chain of thought prompting using few shot examples. Let's try to understand the difference between a traditional or a plain and simple few shot example or few shot prompting versus a chain of thought prompting which leverages few shot examples. On the left hand side, we have a plain and simple few shot prompting, wherein we have a problem statement, a mathematical problem statement for the large language model to solve. That is, a juggler can juggle 16 balls. Half of the balls are golf balls and half of the golf balls are blue. How many blue golf balls are there? This is the problem statement that the large language model is asked to solve. The correct answer for this is 4. Now, in a few shot prompting, what we gives a few examples for the model to leverage from, And based on those examples, we expect the model to learn and give us the right response of the business problem or the query at hand. Similarly, we give this particular example, that is the Roger example, for the model to refer from, and we also give the correct response. So, while solving this particular query, that is juggler query, we ask the model to refer to this particular example given above and give us the response accordingly. But since this is a complex problem, we get a wrong response of 8 instead of 4. When we have a complex problem which multi-shot prompting is not able to solve, we resort to chain of thought prompting. Now let's try to understand chain of thought prompting using few shots. We have the similar problem statement, that is the juggler problem statement, which we are asking the large language model to solve. Instead of giving an example wherein the response earlier we gave it directly as 11, we directly gave the response as 11 to that particular example earlier. Instead of that, we are breaking down the response into a step by step solution where we are articulating the solution at each step so that that particular solution becomes manageable for the large language model to understand and comprehend and give us the right answer at the end. So instead of giving it the answer 11 directly, we are breaking down the response. That is, Roger started with 5 balls, 2 cans of 3 tennis balls each. That becomes 5 plus 6, 11 balls. And that is a final answer. That is breaking down the response instead of directly giving 11, the step by step articulated response. And what we are asking now of the model is, while solving this particular problem statement, the juggler problem statement, refer the example above and try to solve it in the similar step by step manner. And that is what it does. Instead of directly giving the answer, that is 8, which was the wrong answer earlier when we were using traditional or plain and simple few shot prompting, we over in chain of thought prompting, it is dividing its answer into step by step solutions, and at the end giving us the right answer. That is, a juggler can handle 16 balls, can juggle 16 balls. Half of the balls are golf balls, so it has 8 golf balls. Half of the golf balls are blue, so there are 4 blue golf balls, which is the correct answer. It has followed this particular instruction, which was given as an example response, a step by step solution. Hence, we get a correct answer for a complex business problem, which we were not able to get via a traditional or a plain and simple few shot prompting. Coming to the second type of chain of thought prompting, that is chain of thought prompting using zero shot prompting. In zero shot prompting, we do not give any examples for the model to refer from, or we do not expose it to any type of training or fine tuning. It's just a plain simple prompt like this, wherein we give the query, a juggler query that we discussed earlier, and ask the model to solve it. The answer that we get over here, if you see, is wrong, 8, whereas the answer for this particular problem, correct answer is 4. If we are not able to solve it using traditional or plain and simple zero shot prompting, we resort to chain of thought prompting, which leverages zero shot prompting. In this particular technique, what we do is, instead of directly asking the model to solve this particular query, we prefix the prompt and ask the model to solve the problem using a step by step approach. Over here, if you see, we are explicitly saying the model, let's think step by step to solve this problem. What happens is, since we are instructing the model to do it step by step, it will break down the response or the problem statement into manageable subparts and solve each of those subparts in a manageable fashion and give us the correct response at the end. Instead of jumping onto a conclusion at once, giving us the wrong response, as we saw over here on the left in the traditional zero shot prompting, we resort to a step by step solution by instructing the model to do so. So over here, if you see the response, the model itself is going through a step by step solution where it divides the problem statement into manageable parts. That is, there are 16 balls in total. Half of the balls are golf balls. This means 8 golf balls. Half of the golf balls are blue. That means there are 4 blue golf balls, which is a right answer. Now, coming to the last part of the video, where we'll try to implement chain of thought prompting on a Python notebook practically. we'll, similar to the last video where we implemented multi-shot prompting using Flant T5, that is an open source large language model hosted on Hugging Face. We'll be using the same large language model and the same pipeline to do so. To understand that particular pipeline in depth, please refer to the video of multi-shot prompting. For this, we'll be first installing text generation library, which helps us to generate text using large language model, any large language model. From text generation, we import client and inference API client, which help us interact with the large language model hosted on a different infrastructure using an API interface. To leverage these two functions, that is client and inference API client, we built a function that is LLM request function which helps us interact with the large language model. Given a prompt, that is the query which we need an answer for, we'll try to send this particular prompt and expect a response using an API interface. This is what this function is all about, just to give a connection between our infrastructure and the Hugging Face infrastructure via an API interface, so that we send a question or a query with respect to a prompt and expect an output, that is the response. The second function that we create is a prompt creation function using a dynamic prefix and the user query that is being passed as an input function to the LLM request function, which helps us get the response of that particular prompt. Now coming to the solving the problem statement using chain of thought prompting using few shots. Instead of directly jumping to chain of thought prompting, what we'll do is a step-by-step process where we'll first try to solve the problem using zero-shot prompting. If that doesn't work, we'll resort to multi-shot prompting. And if that doesn't work, we'll finally go to chain of thought prompting. So the query that we have for the model to solve is: a juggler has 16 balls. Half of the balls are golf balls and half of the golf balls are blue. This was the problem statement that we saw theoretically earlier. We have made it a bit more complex, adding one extra step, that is half of the blue golf balls are broken. So we want the model to answer how many blue golf balls are broken. If we resort, the first step is using zero-shot prompting, wherein we'll give a empty prefix, nothing, no example. The answer that we get is 4, which is a wrong answer. The second step we do is multi-shot prompting, where we'll be giving an example for the model to refer from. We give an example, a Roger example, with a direct answer of 11. But we again got a wrong response, that is 4. Now to solve this problem efficiently, we'll resort to chain of thought prompting using few shots, wherein we give an example, but the response is a step-by-step process. Instead of giving it a direct answer of 11, which we did over here, we are giving it a step-by-step process to follow, breaking the problem into manageable parts and solve it perfectly. Using this, we are explicitly asking the model that solve the given query in the similar fashion, that is this fashion, breaking the problem statement into step-by-step parts. Over here, if you see the response of the LLM, it is solving that particular problem in a step-by-step fashion and giving us the right response of 2 at the end. This is the power of chain of thought prompting using few short examples. The second type of chain of thought prompting is chain of thought prompting using zero-shot prompting, wherein instead of passing a empty string or directly the query to the large language model to solve, where we got a wrong response or a wrong answer, we are asking the model to think through the process step by step, or break the response into manageable parts and solve each subpart and finally get to an answer. Do not jump to a conclusion or an answer at once. If we ask or we prefix the prompt using this, saying that let's think step by step, the model will think through the process step by step and give us the right answer. This is the power of chain of thought prompting over zero-shot prompting, traditional or plain and simple zero-shot prompting, and plain and simple multi-shot prompting. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.